Okay, so I'm going to go over the notes that we started on the other day. Let me go back a slide. So this is characteristics of graphs of quadratic functions. You're going to need to use Desmos to go through all of these. Okay, Desmos is your friend. So again, in the slide, to type in extra notes, you want to click right here in the box, and then you can type in extra notes. So remember that the vertex is the point at the bottom of the parabola. So let me go to this slide for a second. Not that one. This one. No, that's geometry. Crap. Here we go. Right here. All right. So let's say you have a parabola. Let me draw a parabola. So here's my parabola. Okay. And I don't like that one. Let me move it over some. There we go. So here's my parabola. Now the vertex is always the point at the bottom of the parabola. I'm going to put V for vertex. And remember, your vertex is always HK. So whatever the coordinates of the vertex is, that is your H and your K. The y-intercept is the point on the graph where your parabola touches the y-axis. Okay? So right here, this would be your y-intercept. And it is always the coordinate where 0 is the first number and the second number is whatever the y is. The x-intercept, I don't want that color, purple. The x-intercept is the points on the graph where the parabola meets the x-axis. Notice it says point or points, because a lot of times a parabola will touch the x-axis in two locations. So here we have two x-intercepts, and there's two of them right there, here and here. The coordinates for the x-intercept is always x and then 0 for the y. Now, your axis of symmetry, let me use another thingy. Your axis of symmetry is a line that goes through the vertex of the parabola, like this. Okay? So you will write the equation for that line, and your equation is x equal and whatever the x part of the vertex is. It's always x equal the h for the axis of symmetry. So axis of symmetry is a line. Vertex is a point. Okay? Maximum value. So when your parabola, let's say your parabola is upside down. So I'm going to draw this one over here. See how that parabola is upside down? If your parabola is upside down, then the vertex is at the top of the parabola. And the vertex is your highest point of the graph. So maximum value is your highest point. And that's when the parabola is upside down. You will always use the K value to tell what the maximum value is. Remember, K comes from H and K. Minimum is that first parabola that I drew right here. Okay, so a minimum value, that would be the lowest point of the parabola. So when your parabola is like this, your lowest point is at the bottom of the curve. Okay, yeah, that's your vertex, HK. And remember, you will tell me the K number for the minimum value. So maximum value is the highest point. When your parabola is upside down, your vertex is at the top, which is your highest point. You still need H and K. K would be what the max value is. So here, let me go to this screen. Okay. So right here, shoot, here we go. All right. So here, I already graphed this equation, and I graphed it right here. Okay? When you graph it, you will put it in Desmos. You will find your H, your K, y-intercepts, all that jazz. So start off with vertex HK. When you graph this in Desmos, click on the vertex, and it'll show you the vertex coordinate right there. You don't even have to guess. So clearly I see that my vertex is -3, -0.5. So we put that in, -3, -0.5. That's the vertex, okay? The y-intercept is where the parabola touches the y-axis. That would be right here. See that? That point is at 4 on the y-axis. That means x is 0 and y is 4. X-intercepts. There are two x-intercepts. We got one here and we have one here. Okay? So this one here on the right is at -2 on the x. So that means the point is -2, 0. And we got a second one right over here at -4 on the x. So that point is -4, 0. The axis of symmetry is the h part of the vertex. So here's the vertex. So h is the first number and k is the second number. Well, it says -3. So the axis of symmetry is x equal -3. Maximum or minimum value. Well, the vertex is at the bottom of the parabola, which is the lowest point. So our parabola has a minimum value. And our minimum is at y equals -0.5. Remember, your max or min is always the k value of the vertex or the y coordinate. Okay? Next slide. All right, so here, and I don't know why that creating images is there. But here, I'm going to go to Desmos, and we're going to graph this equation in Desmos. So, where's my Desmos? My Desmos is right here. So let me take that off for a second. So I already graphed the equation in Desmos, right? -4x squared plus 8x plus 2. To find the vertex, I will just click on it right here. And it tells me my vertex is 1, 6. The y-intercept is where the curve touches the y-axis, which is here. If I click on it, it'll tell me 0, 2. The x-intercept, I have two of them. I have one here and I have one here, okay? And they're both decimals, but so what? That happens. So I got these decimals. So let's fill in our table, starting with the vertex. Oh, let me come back to a value. So vertex is 1, 6. Axis of symmetry is x equals, and h is 1, so x equals 1. Y-intercept is right here at 0, 2. So y-intercept, 0, 2. X-intercept, so I got two of them. I got -0.225 and 0, -0.225, 0. And my second x-intercept is 2.2250. 2.225, 0. The parabola is upside down, so my vertex is at the top. That means I have a maximum value because the vertex is at the top. So we got a maximum, and it's at y equals 6. The 6 is the k value of the vertex. Right here it says, what is the a value of our function? Remember, a is always in front of x squared. So our a value is -4, okay? And since our a is negative, that means our graph is upside down, so it flipped, and it also stretched. So it's a flip and a stretch because the 4 is higher than 1. But if you can't remember that, look at it. Right here in Desmos, clearly you see that the curve flipped. And it does look narrower than the parent graph. So narrower is a stretch. Okay? So that's what we have. So one more time, here's what we have. Now, I want to say some other things. So it is possible to have a parabola that does not have an x-intercept at all. I'll show you what that graph will look like. So see this graph? I'm sorry, this one does have an x-intercept. That's some bad business. Let me make that here we go. There we go. Oops. What did I just do? Okay. Sorry. So look at this graph. So here, this is our vertex. This is the bottom of the parabola. The vertex is at the bottom, so this graph will have a minimum. By the way, I'm not doing the other problems with you guys. I'm just showing you different scenarios. So this parabola has a minimum at the vertex, which is at 2 for the k. The axis of symmetry will be x equals 0, which is actually the y-axis. The y-intercept is the same as the vertex. That happens sometimes. See that? Because the vertex is the same point as where our parabola touches the y-axis. This parabola does not touch the x-axis at all. And if that's what you have in any of your problems, then you'll say no x-intercept. So for x-intercept, you would put none. And then I want to show you one more scenario. Let's see. How about I did this. There. So in this case, our parabola is here. See that? And it touches the x-axis at the vertex. So the vertex is a minimum value because that's the lowest point. And you would tell me that the axis of symmetry would be x equal -2 because that's the h value. We have a y-intercept. I will move the graph until I find the y-intercept. It's here, so I'm going to click. And once I click, okay, so my y-intercept is at 0, 16, okay? And yeah, we only have one x-intercept instead of two. So it's possible that you can only have one x-intercept. So I just wanted to show you all of that. So you are responsible for finishing the rest of this table. Do it the same way I did this first example. If you have questions, please let me know. Take care.